Okay, this is again continuation of version 2, but I'm doing the graphing of cotangent transformations and secant transformations. All right, very quickly. Well, actually, secant was pretty straightforward, so I'll just do the cotangent. Some people did struggle with it for some reason. All right, so the graph looks like, well, there's my solution, but I'll actually go through the steps. So it's 4a. And we're talking y equals 2 cotangent 1 half x. Now, a couple of preliminary things. Right away, you should recognize the cotangent looks, what does it look like? It looks like this, right? Well, vaguely. Now, normally, what is my period? Period normally is pi. That's an untransformed. In this case, b equals 1 half. Therefore, my period equals pi over 1 half equals, and reduce that's 2 pi. That's the first thing. And value for a is 2. We know that's going to be a stretch, vertical stretch. Now, is there a phase shift? No, I made the problem very straightforward. There is no phase shift, so I'll just write that phase shift equals 0 or none. All right. But this is the key, to recognize that it's 2 pi is the period. So let's label it. Let's put our graph. Now the cotangent does not go through 0, 0. That's important. One or two of you actually, I think, put it through the middle, through the origin. So we have to recognize that for cotangent, what's actually being stretched by the adjustment of period is the right asymptote. So if we normally have, if this is my pi, this is my 2 pi, my new asymptote will go through 2 pi and the origin, the y-axis. Okay, I recognize that it's going to go through the middle, because that's the midpoint of the period. I also have to recognize that, well, how do I show my vertical stretch? The vertical stretch is shown by what happens to the function at these points, at basically quarter step points, or if you think of it, the halfway of the first period, of the first interval, and the halfway of this interval. And what are those points? If this is pi, this must be pi over 2. If this is pi, this must be 3 pi over 2. Okay. Now, we have to recognize that normally this, it would be going through this point, but because of the vertical stretch of a equals 2, we have to label these points -2. This is 2, -1. Okay, and by placing this point and this point on the graph, I'm getting an idea of what the graph's going to look like. Well, I know, here it's going to tend towards the asymptote, and down here it's going to also tend to the asymptote, but it has to go through these 3 key points. And that was important on the test for me to see that you realize that. And I would kind of freehand connect it. There you go. And there's the graph of cotangent of 1 half x. Again, the asymptotes are important to show, the period, and these points you have to either label it here, or as some people actually label here, and they say pi over 2, for instance. If you label that point, that's perfectly acceptable, but I needed to see this. Anyway, so that's the cotangent function. Should I be doing, should I do the secant? Secant, alright, I guess. Secant is based on, okay, what is 4b? What's secant based off of? Secant is 1 over cosine. So in order to address this, y equals 3 secant x minus pi over 4. I have to think of the cosine, what actually happens to the cosine function, do the transformation to that. Alright, what's my b equals 1, therefore my period's unshifted, so period equals 2 pi. What is my a equals 3? Okay, that's the change in amplitude for cosine, which will affect secant accordingly. Now this is really the key right here. This affects the phase shift. So what's c equals pi over 4, therefore phase shift equals c over b, equal b is 1, so it is pi over 4 is my phase shift. And that's what you have to start with. So we are doing cosine function, graphing the cosine function with the shift of pi over 4. So let's okay, if here's if this is pi over 2, I'm making the scale too big. That's my pi. It's going to be too big. Alright, that's good enough. Actually, we'll extend. Now, what's my phase shift? It makes sure that you realize that it's positive. It's not a negative phase shift. That negative will actually flip the phase shift. So the phase shift is pi over 4. If I label this pi over 2, pi, what was this? 3 pi over 2, and this is 2 pi. This was unphased, unshifted cosine markings, but I realized that my shift will be pi over 4, so instead of starting here, and I should say, 3. Ooh, okay, let's label it like this. 1, 2, 3. Okay, 3, negative 3, 3. Okay, so instead of normally starting here, I'm actually starting shifted over by pi over 4. Pi over 4 is in between 0 and pi over 2, so this is pi over 4. I have to place a point here. And if I were to, okay, let me go through this. All right, so it's going to go through this point. What is this? If this is pi over 2 and this is pi, that's 3 pi over 2. No. Oh, we go in steps in quarters, so this is 1, 2, 3 pi over 4, 4, 5 pi over 4, 6, 7 pi over 4, 8, 9 pi over 4. I know it's getting very, very busy here, but that's unfortunately you got to do that. All right, what happens to my cosine function? The cosine will be going through this point. Let me just refresh so that I'm not, okay, going through this. I'll put them really thick here. My minimum is going to be reached at pi over 4, but at negative 3. Okay, so I'm really getting a big stretch here. 7 pi over 4 gets it, and the final is right here. Oof, that's going to be ugly. All right, if this is my cosine, okay, this is my cosine. What I have to recognize is anytime my cosine hits a 0, I will have an asymptote. Why? Because secant is a reciprocal of cosine. So reciprocal of anytime there's a 0 will be an asymptote to my secant function. So once I got these two asymptotes down, then the work is pretty much done. I have to realize that what the secant does is it acts like this. And at this point it actually touches the point, and it goes down to the asymptotes. And here, well, this is getting in the way, but I think you could tell that we'll reach out towards the asymptote. Okay, here's my function, and here's what was important for me to label. The vertical labels, Or you could have just put down here what this point is. Some people have done that. 5 pi over 4 is my x value, -3. And here it's labeled 7 pi over 4. Here it's 3 pi over 4. Here it's pi over 4, and the vertical is 3. All right. Well, anyway, that's what it looks like. Looking at one period. This is one going from here to here is one full period. Okay. I think this secant problem